I think my sort of the first real test of everything is, can we store the data, the style file data, for example, in TeX Live from 2010 to 2020, 10 years of data? How many gigabytes do we need to store that style file information? Not the sources, not the docs, the style file information. How much resource do we need? And that's, it's roughly speaking, yes, when you make a claim for a gold mine, incidentally, I once drove through a town in Colorado whose name was Aurora. And if you're a classicist, you'll know what that means. And there was a sign that said, city ordinance, no mining within city limits. You're not allowed to dig a hole under the bank because you're looking for gold. But to stake a claim, you actually have to produce ore, and then the ore is assayed to see how rich it is. Well, here, the ore is compression. What degree of compression can be achieved? And that will give you an idea of how much effort it is, how much effort is worth doing. That's one of the things that can be tested fairly quickly, is take all the style files in all the TeX Lives, put them all together in one Git repository. How big is it?
It's not big.
It's not big, but first of all, we don't know how big it is. And second thing is, we don't have a proof of that. And the third thing is, once we've got it, we want to start using it. So on the basis that it's good form to have a census every 10 years, so it's good form to have a compression once in a while, just to see how big it actually is. Mm-hmm. And that by itself may open doors for making better use of the space in TeX Live, for example. I'm not looking for beginning. I'm looking for a beginning to end vision, where the end is something like 2050. But I'm also looking for return on investment prior to the next TeX Live, prior to 2022. So, for example, if we had a tool on TeX Live 2022 that worked for all platforms, that would allow you to typeset a file, and then as a consequence of typesetting the file, produce a pack file, a Git pack file, because that's a convenient interchange format that tells you what the inputs and outputs are. I think that would be a result. I'd like that result. It means that you could typeset something on your machine and then send it off to somebody else, and they could typeset it again. With the usual provisos about platform-specific executables. I think that would be a really useful result. Because when a beginner has got a problem, they can do that thing, and you can solve the problem and send them the result back again. And you can even put that thing straight into Git, so that people, even if they don't know how to use Git, they can create a Git pack. And the only thing that's missing between a Git pack and a regular Git repository is some references to the current, to the latest commit. If you've got a reference to the latest commit, it's now a working Git repository rather than just a Git pack. So that would be, I think, a result that could be done between now and the next TeX Live. And it would put the technology I'm talking about into practical use. And pretty much the only technology it's relying upon is the Git pack file. And the Git pack file contains things like commits, which we're not using, and trees, which we are using. So it requires that technology as well, and it requires the lib. But it's not a big thing. You know, the specs occupy it. It's I have not read the source of TeX from beginning to end. I have read the source of DVI from beginning to end, and I think understood it from beginning to end. Maybe a few things from fonts I didn't quite get. I'd say we're talking about something that's about the same sort of size as DVI, the DVI spec, the DVI